Okay, ladies and gentlemen, this next function is also a rational function. Remember what rational means. It's a ratio of two polynomials. Is f of x a linear function? Well, of course not. No. Does it look like y equals mx plus b? No. In fact, if I asked you in part A a better question, if I said what kind of function is f of x, you would have said it is a rational function. And if somebody asked you to say why, you would have said 5 can be thought of as a polynomial function, x squared minus 3x is a polynomial function, and the ratio of two polynomial functions is called a rational function. Part B, find f of negative 2. Okay, that's easy. We just put a negative 2 in any place we see x into the original function. The numerator remains 5. The denominator, negative 2 in parens squared minus 3 times negative 2 in parens. This becomes 4 plus 6, which is 10 in the denominator, and 5 divided by 10 reduces to 1/2. Last question for this rational function. State the domain of the function using set builder notation. Now, what we do to find the domain of a rational function is we find out what our RVs are, our restricted values, and we throw them out. Well, this problem's a little more complicated than before, so that's why I showed you some work. What causes trouble is if the denominator equals 0, correct? If the denominator becomes 0, we are in trouble. Well, I'll show you how to find the trouble. Make the denominator equal to 0. This equation solves by factoring x times x minus 3, and this equation has two answers, a 0 and a 3. What do we call 0? We call it trouble. What do we call 3? Trouble. Why were they trouble? Because they made the denominator equal to 0. So you can always find your restricted values by creating an equation. Take the denominator of the rational function, set it equal to 0, and solve the equation. Whatever answers come out are your restricted values. So what would the domain be? Well, in set builder notation, the domain would be the set of all x's such that x cannot equal 0 or 3. So in other words, what's the domain? The domain is all real numbers except for 0 and 3. Those are the ones you throw out. Okay, now, the next equation, or the next thing we're looking at here, the next two things we're looking at here, are actually equations. We're going to start with a pretty simple one. 8 over x equals 5, and I just wrote the 5 as 5 over 1. Now, the very first thing I teach my students to do when they're solving an equation like this, because this is called a rational equation, I teach them to state restrictions. So that's step 1. So in this equation, x cannot equal 0. In this equation, x cannot equal negative 16. It's very important to write the restricted value at the beginning of the equation before you even solve it. Now, once you've stated restrictions, this equation's pretty easy to do with cross multiplying. 8 times 1 equals, which is 8, equals 5 times x, which is 5x. When you divide by 5, you get 8/5. The reason I put a circle around this and say, yes, this is my answer, is I know it's not a restricted value. And I did the problem right, which means it's a correct solution. If I look at this next equation, x over x plus 16 minus 3 equals 2. My first step here is not to cross multiply. My first step is to state restrictions. X cannot equal negative 16. And of course the reason behind that is because negative 16 would make the denominator become 0, so that is my restricted value. I am not allowed to use it. Okay? Step 1, when you're solving a rational equation, state restrictions. In this particular problem, what I did next is I added this 3 to both sides, which made this a 5. 5 was 5 over 1, and by writing the problem like this, which is actually called a proportion, I made it very easy to cross multiply. X times 1 is x, and then this other cross multiplication gives me 5 times the quantity x plus 16. When I distribute, I get this becomes 5x plus 80. When I subtract 5x from both sides, I get negative 4x equals 80. When I divide by negative 4, I get x is negative 20. Now the reason I put a circle around this, which means yes, that is a correct answer, it is not a restricted value. If the answer had come out to negative 16 down here, I would have crossed this out and written no solution or empty set as my answer to the problem.